Welcome to the Explainer. Today, we're bringing an incredibly enthusiastic focus to the Cambridge IGCSE physics syllabus, specifically subject code 0625. Our core mission today is simple, but it is an absolute game changer. We want to help you find the back door into every single question on your paper. Honestly, it is time to work smarter, not harder. We are going to deconstruct the exact theoretical foundations and technical methodologies that Cambridge examiners are desperately looking for when they grade your papers. We'll be focusing heavily on the critical and frankly often terrifying areas of reflection at a plane surface, refraction due to a change of speed, diffraction through a narrow gap and at an edge, and the use of a ripple tank to demonstrate wave properties. If you've ever walked out of an exam feeling like you knew the physics inside and out, but still didn't get the grade you deserved when results day came around, listen up. This explainer is going to change absolutely everything for you.
Okay, let's dive straight into the challenge. The principal examiner reports consistently highlight wave behavior as one of the most misunderstood areas in the entire syllabus. But we're going to fix that today by revealing exactly what examiners are searching for. To really understand the trop here, I want you to picture two different physics students taking the exact same 0625 past paper, Alex and Sam. The clock is ticking, the tension is high. When confronted with a complex multi-stage wave analysis question, Alex completely panics and overloads the page with raw physics facts. Alex is writing down everything they've ever memorized about reflection and refraction, just a massive brain dump of formulas, but providing absolutely zero structured analysis. Sam, on the other hand, is rushing against the clock. Sam completely misses the command word requirements of the specific context and forgets all proper formatting. When the examiner's red pen comes out, both students lose massive amounts of marks. Why? Because they both failed to realize that examiners are not just testing your memory of wave properties, they are testing your technical methodology. They want to see logical analysis, evidence-based reasoning, and a crystal-clear approach. That is the true challenge we are conquering today.
So how do we build this system? We're going to map out this complex topic across 5 highly structured sections. We'll start with mastering the mechanics, then move into decoding the core assessment objectives. From there, we'll reveal the incredibly powerful method mark strategy, break down a foolproof problem-solving framework called Deconstruct, Solve, and Evaluate. And finally, we'll look at the top 3 examiner warnings so you can dodge those classic traps. Let's kick things off with Section 1, Mastering Wave Mechanics. We are looking at reflection, refraction, diffraction, and how ripple tanks are deployed in exam scenarios. This is your foundation. Here's the truth. True mastery goes way beyond rote memorization. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, so getting back to the mechanics. The syllabus emphasizes that top-performing students connect causal relationships across entirely different topics. This is exactly where students like our hypothetical Alex goes so desperately wrong. Just memorizing the dictionary definition of diffraction won't save you if the examiner presents a highly specific ripple tank scenario that you have never seen before. The theoretical architecture of wave behavior rests on precise definitions, sure, but it's the causal relationships that get you the marks. You need to understand exactly why refraction happens, specifically due to that change in speed when a wave enters a different medium, so that when the examiner throws a completely novel, unfamiliar context at you, your conceptual understanding transfers seamlessly. You aren't just reciting facts, you are actively applying physics. And to do this, we use the Peel framework. Point, evidence, explanation, link. When you structure your answers this way, examiners literally cannot find a reason to deduct marks.
Moving on to Section 2. Now, what's really fascinating about how Cambridge designs these papers is how they systematically target distinct cognitive domains.
Every single question is engineered to test these 3 core domains, and they heavily prioritize analytical depth over superficial breadth. This shows exactly why overloading a question with random facts, like Alex did, is a doomed strategy. The first domain, knowledge and understanding, well, that's just your baseline. It's knowing that a ripple tank is used to demonstrate wave properties. But the second and third domains, application and deep analysis, that is where the highest marks live. The assessment framework requires logical, structured reasoning based on the command words. If a command word asks you to explain diffraction through a narrow gap versus a wide gap, providing superficial breadth by just defining what a wave is useless. You must apply the principle, deeply analyze the specific gap sizes given in that exact scenario, and structure your reasoning using that Peel framework to prove true analytical depth.
This brings us perfectly into Section 3, the method mark strategy.
This is where we watch the transformation happen. This is how you earn marks for the process itself.
So the absolutely crucial point here is that examiners actively reward your logical, structured reasoning and how precisely you present your working out. The method mark strategy is a grading standard where the presentation of your process matters just as much as your final calculated answer. This requires incredibly strict conventions. You need proper headings, correct terminology, appropriate formats, and crystal clear annotations. Think back to Alex and Sam. If they were to rewrite their answers live right now using this strategy, the transformation would be massive. Alex needs to filter out the noise and just show the logical steps. Sam needs to slow down and actually process the command words. If you were drawing a ray diagram for reflection at a plane surface, your annotations, your carefully drawn normal line at exactly 90 degrees, your arrows denoting the direction of the incident and reflected rays, these are all evidence-based reasoning steps that earn you method marks. It is an incredibly forgiving system if you are disciplined because it actively rewards your process, even if your final arithmetic is slightly off.
Processing any problem within wave behavior follows this exact standardized sequence. This is essentially your physics success blueprint. Let's imagine a classic high-mark past paper question on refraction due to a change of speed. Step 1, identify the key elements. What are the two specific mediums involved? Are we going from air to glass? Step 2, apply the relevant principles. The wave speed changes, which means the direction changes. Step 3, execute your analysis with clear working. Draw your diagram clearly or write out Snell's law before plugging in the numbers. Step 4, verify your results. Look at your diagram. Did the wave bend towards the normal as it slowed down? Did it make logical sense? And finally, step 5, present your findings in the appropriate format with all the correct units. Follow this blueprint and you turn red pen marks into green check marks every single time. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's jump right into section 4. Deconstruct, solve, and evaluate. This is where we turn strategy into an interactive workshop. When you're tackling these examination questions, I want you to treat it like a high-stakes 60-second data scan challenge. When you look at a complex physics chart or a dense diagram of a ripple tank demonstrating diffraction at an edge, do not just start writing. Sam lost marks because Sam rushed. You have to follow this timeline. Step 1, deconstruct the question. What is the command word actually asking? Step 2, extract the relevant data from the scenario. Filter out the distractor information. Step 3, select your analytical framework. Are we dealing with reflection, refraction, or diffraction? Pinpoint the exact physics. Step 4, execute with clear notation. This means using the exact correct terminology for wave behavior. You don't say the wave bends a bit, you say it refracts towards the normal. By following this timeline chronologically, you solve the problem in a highly structured way, securing those method marks at every single step. Now, let's do a quick find the flaw challenge mentally. To hit the absolute highest evaluative levels, you must question assumptions, consider different perspectives, and justify all your decisions with evidence. The framework for Cambridge physics comprises descriptive, analytical, and evaluative levels. Top-scoring candidates don't just describe what a wave does, they demonstrate true evaluative thinking. If a question gives you a paragraph about adjusting the frequency of a motor in a ripple tank, and a student just writes, "the waves get faster," that's a flaw. A higher-order answer will evaluate how that alternative frequency directly impacts the wavelength, and subsequently, how it alters the specific diffraction pattern through a narrow gap. You must back up every single claim with hard, justified evidence from the principles of physics. Look at this quote directly from the Cambridge Principal Examiner reports. This is the ultimate backdoor strategy right here. It proves that integrating concepts across the syllabus is the secret to maximizing your score. The theoretical architecture of wave behavior does not exist in a vacuum. It rests on integration with other syllabus areas. So, if we were doing a speed writing challenge right now, a perfect Peel paragraph would link the kinetic energy of the mechanical motor driving a ripple tank to the amplitude and the energy of the actual waves produced. When examiners see you making these brilliant cross-topic connections, they immediately recognize a top-tier conceptual understanding. You are showing them that you see the whole integrated physics picture, not just isolated, disjointed chapters. And that brings us to our final section, Section 5. We're going to build the ultimate cheat sheet by looking at the top 3 examiner warnings, ensuring you avoid the classic mistakes that trap thousands of students every single year. Examiners explicitly warn against these 3 procedural mistakes. These are the completely avoidable errors that repeatedly drag down student grades. Warning number 1, students forget to include proper format in their wave behavior answers. This means missing units, drawing messy, unannotated ray diagrams for reflection, or providing calculations that are impossible to follow. Warning number 2 is closely related to the time management matrix, rushing at the end and forgetting to double-check that format and presentation. But warning number 3, this is the absolute biggest trap of them all. Examiners report year after year that the classic mistake is providing generic answers that are not specific to the context given. This ties perfectly into our 3 rules that guarantee top marks. Rule 1, command word decoding. Rule 2, Peel framework application. And Rule 3, the time management matrix. If you ignore these rules, you fall right into warning number 3.
This dynamic right here illustrates everything we've talked about today. Generic answers fail entirely, while context-specific connections are the master key to unlocking the highest grade boundaries. If a past paper question asks about the diffraction of water waves around a specific harbor wall, and a student simply writes, "Diffraction is the spreading of waves at an edge," that is a textbook generic answer. It is a memorized fact with 0 situational relevance. It totally ignores the harbor. The context-specific answer, the one structured with the Peel framework that secures maximum marks, would explicitly link the wavelength of the ocean waves directly to the physical size of that exact harbor wall to explain the specific diffraction pattern observed in that unique scenario. Always link every single point directly to the given scenario.
Students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. As we wrap up this explainer, I want you to ask yourself one final, critical question. Are you just blindly memorizing definitions like Alex? Or are you building the technical methodology required to deconstruct, solve, and evaluate like a true top-tier student? Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for physics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Mastering this analytical process is your true backdoor to exam success. Keep practicing, and I'll see you next time.